Hi guys, I'm Kimberly Gutierrez of BET-CPET 2BNS. So for today's video, I'm going to do the experiment number 10, which is the multivibrators and the SR flip-flop. So let's start doing the circuit 1 and 2 of this experiment. So in this experiment, I'm going to use 5 volts DC power supply, 74LS00IC, 5mm red LED, SPDT switch, breadboard, jumper wires, and last is the alligator clip. So first, I'm gonna do the circuit 1 and I'm gonna put the IC on the center of the breadboard. And next, I'm gonna put the SPDT switch on the side. And I'm gonna put the 4 LED on the breadboard. And next, I'm gonna connect the switch 1 to the positive side of the first LED or in 1. And next, I'm gonna connect the right side of the switch 1 to the negative side of the power supply. And I'm gonna connect the left side of the switch 1 to the positive side of the power supply. And I'm gonna connect the negative side of the in 1 to the negative side of the power supply. And I'm gonna connect the switch 2 to the LED 2 or in 2. And I'm gonna connect the right side of the switch 2 to the negative side of the power supply. And I'm gonna connect the left side of the switch 2 to the positive side of power supply. And I'm gonna connect the negative side of the LED 2 or in 2 on the negative side of power supply. And next, I'm gonna connect the pin 1 and pin 2 on the positive side of the LED 1 or the in 1. And next, I'm gonna connect the pin 3 to the pin 12. And next, I'm gonna connect the pin 4 and pin 5 together, and I'm gonna connect them to the LED 2 or in 2. And next, I'm gonna connect the pin 6 to pin 10. And next, I'm gonna connect the pin 9 to pin 11. And I'm gonna connect the pin 11 to in 3. And I'm gonna connect the negative of in 3 to the negative side of power supply. And I'm gonna connect the pin 8 to in 4. And I'm gonna connect the negative side of in 4 to the negative side of power supply. And I'm gonna connect the alligator clip to the breadboard and the power supply. So this is the output of the circuit 1. So I'm gonna do the truth table of the circuit 1, and I'm gonna turn on the power supply. And as you can see in the first row of this truth table, the S1 and S2 are both off, and the output in 1 is off, in 2 is off, in 3 is on, and in 4 is off. But when I turn on this switch 2 and turn it off again, the output has changed and the in 4 is now on and the in 3 is off. So instead of answering 0, 1 and 1, 0 in the output, we're gonna put memory because the output of the first input has not changed. And in next row, I'm gonna turn on the S2 and the S1 is turned off, and as you can see the output is in 1 is off, in 2 is on, in 3 is off, and in 4 is on. Next, the S2 is off and the S1 is on, and as you can see the output in 1 is on, in 2 is off, in 3 is on, and in 4 is off. And in last row, the S1 and S2 are both turned on, and as you can see the output in 1 is on, in 2 is on, in 3 is on, and in 4 is on. But instead of putting them on in the output, we're gonna put not used because its output is indeterminate or unpredictable. So in circuit 2, I'm gonna add one SPDT switch and another LED. And next, I'm gonna remove the connection that connects the pin 1 and pin 2 and the connection that connects the pin 4 and pin 5. And I'm gonna connect the pin 4 and pin 2 and I'm gonna connect them to switch 3 or the clock. And I'm gonna connect the right side of the SPDT switch or switch 3 to the negative of power supply. And I'm gonna connect the left side of the SPDT switch to the positive of power supply. So I'm gonna connect the SPDT switch or the switch 3 to the positive side of the LED. And I'm gonna connect the negative side of the LED to the negative of the power supply. So I'm gonna connect the power supply to the breadboard. So here is the circuit 2, and I'm gonna connect the power supply to the breadboard and open the power supply, and I'm gonna do the truth table. So here in the truth table, the switch 1 is off, switch 2 is off, and switch 3 or the clock is off. And as you can see, the output in 1 is off, in 2 is off, in 3 is on, and in 4 is off, and in 5 is off. And again, we're gonna answer memory in this row because when I turn on the switch 2 and turn it off again, it will become a memory. And if I turn on the switch 1 and turn it off again, it will become a memory. And when I turn on the switch 3 and turn it off again, nothing's happened in the output, so it will also become a memory. So next, I'm gonna turn on the switch 2 and the switch 1 is off. And you can see the output in 1 is off, in 2 is on, in 3 is still on, and in 4 is still on, and in 5 is off. And when I turn on the clock or the switch 3, the output will be in 3 is off, and in 4 is on, and the in 5 is on. And next row, I'm gonna off the switch 2 and switch 3, and I'm gonna on the switch 1, and switch 2 is off and switch 3 is off. So the output is in 1 is on, in 2 is off, in 3 is on, in 4 is on, and in 5 is off. And when I turn on the switch 3 or the clock, the output in 3 is on, and in 4 is off, and in 5 is on. And in the last row, the S3 or the clock is off and the switch 2 is on. So you can see the output in 1 is on, in 2 is on, in 3 is on, in 4 is on, and in 5 is off. And when I turn on the S3 or the clock, all of the LED are on. And like the previous truth table, we will gonna answer not used in this row because the output are also indeterminate and unpredictable. So that's all from this experiment. I hope you learned something from this video. Thank you.